Hello, welcome back. This is Yo-Yo. Today we are going to talk about domain and range. So, one of the main goals in mathematics is to model the real world with mathematical function. In doing so, it is really important to keep in mind that the limitation of those function models we created. So, here's a table. So, here's the table. So the table shows the relationship between the circumference and the height of the tree as it grows. So these are the data that they connected. When the circumference is 1.7, let's say feet, the unit is feet, and then the height is 24.5 feet height, and then when the circumference 2.5 feet, and then the height 13.1 feet height. So while there is a strong relationship between these two, it would certainly be ridiculous to talk about the tree with a circumference with a negative 3 feet, right? Or the height with 3,000 feet. When we identify the limitation on the input and output of a function, we determine the domain and the range of a function. So, by the definition, a domain is the set of the possible input value to a function, and the range means the set of the possible output value to a function. So now it makes sense. When it comes to the domain, represent the set of possible input value. So we know that as we use the previous example, it's ridiculous for us to say, hey, negative 3 is in the domain. No, because you can't have a negative 3 feet of the circumference of a tree. Also similar to the height, you can say, hey, the tree grows 3,000 feet high. This is really impossible, right? So when we say that, so we could combine the data that we had with our own experience and the reason to approximate the domain and the range of the function of the tree height. Okay, so for the domain, the possible value for the input of the circumference, C, it doesn't make sense to have a negative value, right? So C has to be greater than 0. And we could make a educated guess at the maximum reasonable value or look up the maximum circumference measured. In the world record, it's about 119 feet. So I would say the circumference of a tree should be in between 0 to 119 feet. So with this information, this is a reasonable domain for us. So similarly to the range, by looking up, we will say the highest tree right now, as they discover, is 379 feet tall, and also they can have a negative number, so H should be in between 0 to 379. So this is going to be our domain. Okay, so let me give you another examples. So look at the graph on the upper right. So when you're sending a letter through the USPS, which is the United Postal Services, the price depends upon the weight of the letter, as shown on the table on the upper right. Determine the domain and the range. So now let's take a look. If the letter weight at 1 ounce, the price is going to be 14 cents. If it's 2 ounces, the price is going to be 61 cents. and 3 ounces is going to be 78 cents. 3.5 ounces is going to be 95 cents. So we know that by what we learned in the previous section, this is a price. This is a function of price given by what? The weight, right? So this is our function. So what would be the domain? Since the acceptable weight is what? Look at the graph. Look at the table and think about what is the acceptable weight. Acceptable weight would be what? 3.5 ounces or less. So based on your real life experience, if you're melting something 0.8 ounces, do you think they will accept it since they only have the price of 1 ounces? They will still accept it, right? But they will count it as 1 ounces. But the thing is, even though you're less than 1 ounces, they will still accept melted as their letters, right? So that means the domain would be what? Again, when you're melting something, you can melt something that less than 0, which is a negative. So the domain of the weight should be 0 ounces to 3.5 ounces, right? Because sometimes, think about the experience. If you're above 3.5 ounces, they will ask you to, hey, you can melt it as a letter, you need to melt as a package. They will charge you as the package rate instead of the letter rate. Okay, what about the range? The range means the price. So what would be the cheapest price? Again, let's use this example. If the letter weighed 0.8 ounces, how much do you think they will charge you? Well, they charge you at least, 14 cents, right? For the price. So what's the highest limitation that they can charge you? $0.95. So is this the right way that we can write down the range? Well, we can think about that. So if, based on your experience, think about if your letter weighs 1.5 ounces, how much do they charge you? Do they charge you between 44 cents and between 44 cents and 61 cents, which is, let's say, 50 cents? They don't do that, right? They just charge you to the next level, which is 61 cents, right? So that means this is incorrect for us to write down the range because it's not the number between 44 cents to 95 cents. It's more like a bracket. They either charge you 44 cents or 61 cents or 78 cents or 95 cents. They don't charge you in between. They don't charge you 50 cents. They don't charge you 70 cents. If you're 0.8 ounces, like I say, they are not going to charge you 13 cents. They are going to have to charge you 44 cents. So here is the range. The range is going to be a set of number. It's not continuous. It's more like a discrete. But when it comes to the domain, it's going to be a continuous because there's no way that, hey, your letter weighs 1.5 ounces. Okay, sorry, we can melt it because it's not 2 ounces. You need to make it 2 ounces, right? So again, you need to think about, we want to use math in real life. How do you going to deal with these problems? So now let's look at this example. The population of a small town in the year 1960 with 100 people. Since then, the population has grown to 1,400 people. Reported during the 2010 census. Choose the independent variable, dependent variable. Use the interval notation to write the domain and the range. Okay, so now let's take a look. So, what will be the dependent variable? What is independent variable? Independent variable means the input. Dependent variable means the output. So, when you do the census, it's more like you put in the year, the output is going to be the population. So you have 1960s, the output is going to be 100 people. And then you put in 2010, and then the output is 1400 people. So the input should be the year, and the output would be the population. Okay, so what's the domain and the range? Since they only connect two data, right? One is 1960s, the output is 100, and then the other one is 2010, the output is 1400. So the domain, we only have two data. So the domain should be 1960s and 2010. It's not continuous because they didn't connect any data in between these 2 years. And then the domain is going to be a set of two data points. And the range is going to be what? 100 and 1400. That's it. Okay, so next time we're going to talk about how we're going to write the notation. So when it comes to the notation, let's talk about one thing is when it comes to discrete, like here, this is discrete data, right? Means they're not continuous. We didn't continuous to report every year like 1961, 1962, 1963, right? So the notation of discrete data is we use a cursive and write down everything that we have in here, every data point that we have. Okay, so that part is easy. This is for discrete. What about a continuous data point? Like the way that we have in the previous example, such as the way if it's in between 0 to 3.5 ounces, we have a couple ways to do it. One is called set builder. Which is going to look like we're talking about weight, and then the weight is in between 0 to 3.5 ounces. This is set builder. Or something like if the domain or range x is in between 13 to 10, when we write it into set builder, it's going to be x is between 10 to 13. Another way to do it is called interval notation. Such as we represent like 10 to 13, we'll write it as from 10 to 13. Bracket means including. And then if you see a parenthesis like 10 to 13, that means 10 is not including the endpoint. What's the difference between these two? This means x is less than or equal to x, 10. X is greater than or less than 10, greater than or equal to 13. But when it comes to the second one with the parenthesis, not the bracket, means 10 is less than x and x is less than 13. There's no equal sign. That's the differences. Or if we write something like h is in between 10 to 5, which means we call it half open or half closed. So I can write it, since there's an equal sign, I need to have a bracket on the 5 end, means including the 5. And there is no equal sign on the 10 end, so I use bracket 5, comma, and then 10 parentheses. Okay, what if something like x greater than 10. That means from 10 to infinity, right? So since infinity, you can include in infinity, so I can have 10 to infinity. It's always, when it comes to infinity, it's always a parenthesis. Or I have x less than or equals to 5. That means everything less than 5. So I should have negative infinity, remember? No bracket to 5. 5 is including. Okay, so what about all the real number? Everything you including. So that is going to be negative infinity to positive infinity. Or sometimes they will use the notation, means all the real number. You write r with 2 slash. Okay. So the other way to do it is use a graph, such as h in between 5 to 10. We draw it on the number 9. This is 0. This is 10. This is 5. Oh, I'm sorry. This is h. Oh, let me draw a better one. This is bad. I've had 0 here, 5, 10, negative 5, right? So x is in between, h is in between 5, including 5, but not including 10. So that means when it comes to 5, let me use different color. When it comes to 5, we have a solid dot. That means including and everything in between 5 to 10, but not including 10. So we have empty circle when it comes to 10. So what about infinity? Like these two. Let me draw another two, number 9. So how can we do this? Okay. If I want to say, hey, x is greater than 10. So x is not equal to 10, right? That means there's a circle when it comes to 10, and then everything greater than 10. But I can keep drawing. What are you going to do is you put an arrow in here. That means everything greater than 10. So similarly, when it comes to x less than 5, so what we're going to do is, since it's including 5, since it's including 5, so you need to have a solid dot on 5, and everything goes to the left, because the left is the negative infinity, and then we put an arrow. So I will know. Okay. So now we're done with the notation. Now let's determine the domain and the range by giving a graph. Okay, so the last part of this section I want to talk about is piecewise function. Oops. So that means the function, a piecewise function, is a function in which the formula used to be upon by the domain. Let me just give you an example. I think it's really complicated. Just write it. Let's use the example of the USPS postal office. Let me find the graph. All right, that's another graph. Let's find the table. So, okay, how can we determine this? Let's say the price is the output, the weight is the input. So, if the letter weighs in between 0 to 1 ounces, how much would you charge them? Let me write it into a function notation, which is in between, the way in between 0 to 1 ounces. How much would you charge them? How much the price should be? 14 cents, right? But what about, let me write it a little bit to decide, because it's blocking it. So this is a price function. So if the weight is greater than 0, they start charging you, and equals to 1 ounces, including 1 ounces. How much should they charge you? 14 cents. Like the previous example that I told you, if the letter weighs like 0.8 ounces, they still charge you 14 cents. Okay, so when do they charge you 61 cents? When the weight in between 1 ounces, but not including 1 ounces. Why? Because if it's equal to 1 ounces, they're supposed to charge you to 44 cents. But if your letter is 1.1 ounces, which is greater than 1 ounces, even though just a little bit, they're going to charge you 61 cents. So that means in between 1 ounces, but not including 1 ounces, less than or equal to 2 ounces, they're going to charge you 61 cents. And then when do they charge you 78 cents? Well, when the weight is in between 2 ounces to 3 ounces, but not including 2 ounces, including 3 ounces. So similarly to the last one would be between 3 ounces to 3.5 ounces. So this is a piecewise function. That means the price, the output, is depending on different set of input. So now let's say I give you a cell phone company use a function below to determine its cost. So this is cell phone company. Let's say depending how many gigabyte they use. G means gigabyte, C is the cost. 25, and then 25 plus 10G minus 2 if okay. Oh, let me close the window so it won't block it. So this is a cell phone company use the function below to determine the cost. Well, C means the cost, G means the gigabyte of the data that you transfer. This is really common in day-to-day life, such as you think about your water consumption. They charge you not just by the flat rate. They give you a flat rate. If it's under a certain amount, you're going to charge that, and then when you're above that amount, they're going to charge you differently. Oh, I know what is the most common example, which is the tax bracket, right? If you're below 3,000, they're going to charge you 10% of your tax. If it's above 3,000, they're going to charge you 20% of the tax, something like that. Okay, so when you look at that function, what does that mean? How do you interpret the function? Well, let's take a look. G is the gigabyte, is the data that they use. When G is between 0 to 2, they charge you 25. That means what? How do you write it into the language that we understand? That means if your data if you use less than 2 gigabyte data, they're going to charge you a flat rate, $25, right? But if you use more than or equal 2 gigabytes of data, they're going to charge you what? $25 plus 10 minus 2. So let's say if I use 1.5, let's find out the cost of using 1.5 gigabyte of data. What would be the cost? Well, it's less than 2, so that means I need to use the first formula, right? So the cost would be $25. That one is easy. What about I want you to find the cost of using 3 gigabyte of data? Well, 3 gigabyte, I'm going to use a red pen, since the gigabyte G is greater than 2, so that means I need to use the second formula to find out the cost. So that means I need to substitute 3 into the function. So I have a 25 times 3, G substitute with 3, okay? Minus 2, which is equal to 25 plus 10, which is equal to 13.5. That means if you use 3 gigabytes of data, you're going to pay $35. So this is a piecewise function. We can draw a graph on a piecewise function. So how do we do that? So now let me draw the graph. Since data is always a positive, we talked about that, that's the domain. There's no way you will have a negative data. Even though you didn't use it, that will consider as 0. You can give them back. So I have this is gigabyte of data that you use. This is the cost. You have 25, 13, 13.5, 40. Okay, so now take a look. So the first part is here. I'm going to use different color of pen. Let's use blue for the first function. For the first function is when G is in between 0 to 2. That means from here to here, right? I circle it. Your cost is going to be a 25. 25 means it's a flat line. No matter how much you use 1.5 gigabyte, it's going to charge you 25. You use 0.2 gigabyte, they still charge you 25. So that means it should be a circle because it's not including 2 and 0. They're going to charge you 25. Okay. So the second part of the piecewise function is in here when it's greater than 2, including 2. That means the n is going to include 2 to infinity. And then the function, you need to draw the function of that. 25 plus 10 G minus 2. So I will have what? When it comes to 2, you will have, this is a linear function. When it comes to 3 gigabyte, they're going to charge you 13.5. And you connect these two dots together. So this is the line. This is what the function looks like. It's going to be a linear function starting from 2. So that means the function is going to combine with 2 parts. The first part is the function 1. When G is less than 2, but not including 2. So that's why when it comes to blue dot, it's going to be a circle. And then the second part of the function, which I draw in red, is starting with 2, including 2. So that's why the left end is going to be a solid dot. And then going to be a linear function. Go all the way up. Okay, that's it for today's class. Piecewise function can be confusing, so please let me know if you have any questions.